In this video, I'll demonstrate a technique to help you understand how curve fit parameters impact the shape of a fit to help determine good starting point estimates. I have open a spreadsheet with the data I'd like to fit a user-defined curve equation. I have the curve fit equation here, and I've gone ahead and calculated my parameters using the user-defined advanced function. I've also created a curve chart showing my fit line in blue and my calibrators in orange. For more information on the user-defined advanced function and creating a curve chart, please see the associated videos. You can see from the fit here that it doesn't appear to model my data very well, and it's probable the starting point estimates could be improved. I would expect this curve fit to be more sigmoidal in nature to model my data. However, if I'm not familiar with the curve fit equation, it can be difficult to determine what appropriate starting point estimates might be. To help with that, we'll use this parameter exploration chart and data table over to the left. I've added a table containing the parameters included in my curve fit, A, B, C, D, and M. I've added the default starting point estimates of 1 for each parameter. Now I've added our x values to at least span the range of the x values in our dataset to this table, which will be the data plotted on the chart. Instead of allowing the MyCurveFit Excel add-in to generate parameters for us, I'm going to use the user-defined calc_y function and input these parameter values to be used in the curve fit equation. This way, the chart will be updated based on the input we provide for the parameter values. I'll enter equals MyCurveFit and select the user-defined calc_y function. I'll select the values for my parameters, press F4 to denote an absolute reference, select the x value, and finally the curve fit equation, again pressing F4 to denote an absolute reference. I'll drag the formula down to fill the rest of my y values, and you'll see we now just have a straight line for the fit plotted on our chart. Now we can start to update the parameter values for our fit and see how that impacts the shape of the curve. Remember that negative values and fractional values can also be used. Let's start with the A parameter. I'll enter a value of -1, and now we can see our curve starts a little before 0, trending upwards, leveling off. Reviewing this, I would believe that the A parameter could represent a lower asymptote of the curve. Now let's make a change to the B parameter. I'll enter a value of -1, and we can see this flips the direction of the curve and forces it to appear below the x-axis with negative y-axis values. Let's try 0.5. This flips the curve again, and now it's appearing above the x-axis. So this information tells me the B parameter likely has something to do with the slope of the curve. Now let's look at the C parameter. I'll again enter a value of -1, and this causes the curve to be incalculable, so we know that's not an option. I'll return the C parameter to 1 to reset the chart. So we know the C parameter cannot be negative for this data set. So let's see what happens when we enter a value of 10. That changed the shape of the curve and the range of the curve. Let's try 100 and see what happens. So we can again see the shape of the curve has changed. If we imagine a sigmoidal fit line, it's almost like updating the C parameter changes the shape of the sigmoid, imagining that we're only seeing a snippet of the full curve displayed on the chart. I'll return the C parameter to 1 to have the curve mostly above the x-axis and just to help me visualize the other changes, since at this point I'm not totally sure exactly what the role of the C parameter is in the fit, but I'm thinking it may have something to do with the center of the curve. Now let's update the D parameter. I'll try -1, and interestingly, this returns the fit to a flat line. Let's try 100. So this brought our y-axis values way up. If I'm looking for a sigmoidal fit, logically I know there should be two asymptotes. If the A parameter is set to -1 and the D parameter is also set to -1 and the fit fails, then it stands to reason that the D parameter may represent the other asymptote of the curve. Finally, let's take a look at the M parameter. I'll enter a value of -1, and we can see this flips the direction of the curve. How about 0.5? That flips the curve back into the right direction for our data and flattens the curve a little. At this point, I'm not totally confident what the M parameter represents, but it may be unnecessary to add a custom starting point estimate for this parameter. Let's take what we've learned and try to apply it to our dataset. So we've learned that the A parameter and the D parameter are likely representative of our asymptotes. Looking at our dataset, I'd like the lower asymptote of the curve to be close to the minimum y-axis data point. I can manually enter a value of 128 for the A parameter, or I could use a heuristic expression and enter equals min and highlight our y-axis values. This will return the minimum value. Similarly, I'd like the D parameter to be close to my maximum y-axis value, so I can either enter manually 3708 or enter equals max and again highlight our y-axis values. This will return the maximum value. So with that value entered, you can see that our curve looks great now, modeling our data quite well. So for this data set, I don't think we need to add starting point estimates for any of our other parameters. This curve fit equation is actually a 5-parameter logistic regression, and with that information we can research what each parameter represents. The A and D parameters do represent the upper and lower asymptotes. The B parameter is the hill slope, and the C parameter is the midpoint of the curve. The M parameter is an asymmetry factor. However, just by using the tools available and looking at the fit, we were able to ascertain enough information about how the parameters impact the fit to be able to create good starting point estimates for our fit. If you have any questions about exploring parameters and their impact on the curve, please email us at support@myassays.com.